feel like it's time.
Yeah, watching that clock. Oh, and we're on the clock.
All right. And we're off. It's a good one, isn't it?
That's right. See you next year.
All right, welcome to Pass the Hash, how attackers spread and how to stop them. My name is Mark Krasinovich, and this is
Nathan Ide.
And I'm a technical fellow in the Azure group at Microsoft. Nathan is a dev manager in the Windows security team.
That's right.
The reason that we're presenting this together is people are sick of me giving cloud talks, and so I just said, Nathan, let me give a talk with you that's not a cloud talk. How many people are sick of cloud talks? Yeah. So it makes me so sad. But this is not a cloud talk. This is an on-premises talk, as we call it in the business. And the reason that we're working together on this talk is that leading into the development of Windows 8.1, we were focused in Azure at getting compliance under control, compliance for our infrastructure that accesses Azure production, as well as Azure production itself. And as auditors were coming through, we started to realize that, as they pointed out, and we realized, that pass the hash is a significant problem on any kind of Windows network. And there were places where we'd not properly prevented the spread of pass the hash. And we'll explain what pass the hash is in a second. So what I did is I sat down with a few other people at Microsoft, including Nathan and others in Azure and Windows security and actually the field as well, to brainstorm how could we help people get a handle on pass the hash, not just for them, but also for us internally at Microsoft. And so we came up with a set of features that we're going to cover this afternoon that have made its way into the product and give you some new tools in the tool chest for stopping pass the hash spreading throughout your network. How many people know what pass the hash is? So quite a few. How many of you showed up at the session like, pass the hash, I don't know what that is, but it sounds really fun? So, and actually I was going to say that pass the hash is a problem for many of you. But for some of the lucky ones, it is actually not a problem anymore. It's actually encouraged. If you've got the hash, you're encouraged to pass the hash. So, but for the rest of you, and actually Nathan and I do happen to live in Washington, so this is really awesome guidance for all of you that don't. So let me talk about pass the hash. Pass the hash has this reputation of that's the Windows problem. Windows has this problem. It's pass the hash. And man, hackers just love taking advantage of pass the hash, and then they own the whole network just boom like that because of the sucky Windows pass the hash problem. In fact, this is a misconception, a fundamental one, about what pass the hash is and its relationship to Windows. Pass the hash equals single sign-on. Any system that supports single sign-on is susceptible to a pass the hash attack. And I'll cover exactly what pass the hash attack is in a second, but basically it is somebody uses credentials to log onto a system, and then some form of that credential or the actual credential allows them to go and access other resources without having to retype or re-enter their initial credentials. That capability is really powerful. Our end users love it, and we love it too. When you log into a system and then you go to the SharePoint site, not having to type in your password again. When you access a file share, not having to type your password again. When you print something to the printer, not having to type your password in again. And that's the power of single sign-on. Otherwise, well, the only exception in the Microsoft world is Outlook, where you've got to type in your password all day long, 15 times a day. But that's Outlook, not Windows. But given that problem of having to retype in not type in your password, or that benefit of not having to type in your password, you end up with these credentials that an attacker, if they get on that box where those credentials are stored, can grab them and then use them to access other resources as you. So this is a problem that there is no fix for. You cannot fix it without killing single sign-on. And of course, completely killing single sign-on is an extreme measure that some organizations go to, especially the military organizations where they're using key fobs with one-time use passwords, and you've got to authenticate to everything anytime you want to touch it. No single sign-on there, and that is because they want to prevent and completely avoid this type of problem. But as long as you want single sign-on, there's no fix for this problem. Also, just in terms of terminology that you'll hear us use throughout this presentation. There are two types of pass-the-hash attack. One is credential reuse. That is when somebody grabs your credential or credential verifier, and then they, from the system that it's stored on, use that to go authenticate to other resources as you, without your knowledge. This is reusing that credential verifier credential that you've entered into the system. And then the second form we call credential theft. And this one is, attacker gets on your box where you've got your credentials stored, and now they grab those credentials and then take them to another location and use them from there. And this one lets them spread throughout a network. It's through a process we call credential harvesting that we'll cover. So those are the two forms. Reusing it from where it is, as you, to access other resources and spread to those other resources, and then also taking those credentials with them as they do that is credential theft. Here's the agenda of the talk that we've got for you over the next 75 minutes. We're going to take a deeper look at the pass-the-hash technique to show you how an attacker actually uses those two types of attacks to spread through the network, just to spend a few more minutes on that. Then we're going to talk about pass-the-hash in Windows, so what kinds of tools and techniques are hackers using to harvest credentials and to use the credentials that they harvest to spread throughout a network. And then we'll get into what are the mitigations that have been introduced in Windows 8.1 and Server 2012 R2 that enable you to try to prevent, to mitigate the effectiveness of pass-the-hash throughout your network to protect your high-value assets and users. And those include, we break that down into local account mitigations, mitigations against passing the hash on domain accounts, mitigations for restricting remote administration access, RDP access, and compromise of credentials in that scenario. And then finally, a feature that is actually a collection of features that together allow you to create what we call authentication policies for certain users and silos that those users, silos of resources those users can access to contain pass-the-hash. So let's talk about single sign-on just a little bit more. This is Sue logging into her laptop, and when she logs into her laptop, and this is a Windows-centric perspective on this, so Sue enters her password. Now Sue gets a user session on that laptop after she's authenticated to it, and her password verifiers, in this case, in the case of Windows in this particular example, we're using a one-way hash, also known as an NT one-way function of her password that's stored on the box. And now that that's there, she can go access a file server. And when she accesses the file server, there's a challenge response from the file server to have Sue prove that she really is Sue. And what happens underneath the hood is that Sue proves that she knows the password by using that one-way function in that challenge response. So once Fred then knows that Sue knows that password that Fred is also aware of, or that file server is also aware of, then Sue gets a session on that file server and now can access the files on that server. In the pass-the-hash attack, we've got Fred. And Fred's got a user session here. He's already authenticated, so he's got his one-way function stored in the system. Now a bad guy takes over Fred's machine. Or Fred himself is malicious. And now Fred, or the malware, takes that password hash and authenticates or copies it to its own session potentially, so it's not reliant on Fred being logged in any longer, and this would be a theft scenario. Takes that credential, so now Fred can actually log off, his session destroyed, but the malware has Fred's one-way function, his hash, in its own session, and now it can go around the network as if it's Fred. So the malware attackers usually perform some kind of reconnaissance, either beforehand or while they're got their presence on that server. So they'll do port scanning and check out what file servers are accessible to this machine, and then they identify targets to go to. This is called lateral movement throughout the network. And so they'll say, oh, Sue's laptop. Looks like Sue's laptop might be an interesting target, and let's try to authenticate using Fred's credentials to Sue's laptop. And assuming Fred has access to Sue's laptop, then a session can be established for the malware on Sue's laptop. What makes it worse is if Fred has local administrative access or rights on Sue's laptop. With the local administrative rights, now the malware can now harvest Sue's credentials off that laptop. And so this is the credential harvesting now. The malware has Fred's credentials, the malware picks up Sue's credentials, and Sue, let's say Sue's a domain admin. If Sue's a domain admin, now the malware has domain admin credentials, and say this is the domain controller or a domain controller file server, file share on the domain controller. Now the malware presents itself as Sue to that system, and now the whole network is owned at that point through this lateral movement, collection of, or harvesting of hashes, and now ultimate owning of the whole domain. In fact, when we talk to Microsoft Consulting Services and they get called out for breach incident response at corporate environments, I mean, I would estimate, I don't know what the exact percentage is, but the 99% of the cases where the domain has been owned, it has been owned through this exact technique of lateral movement through past the hash. So this is a huge, huge problem. Small companies, big companies, military organizations, government organizations, giant EU organizations we know that have had their whole domain taken over using this technique. So now Nathan's going to talk about Windows and past the hash.
Thank you. I know what you're thinking. Beard, glasses, computer guy? I'm fulfilling the quota for the stereotypical computer dude. So as Mark had indicated, I'm a developer. I'm a dev manager in Windows. I'm responsible for authentication and single sign-on in Windows. So we've spent quite a bit of time working on past the hash. And in this audience, many hands raised, many people are familiar with what it is. Sadly, past the hash is no longer something that is just in parlance in industry circles like this. Its effects are actually felt across the world. One of the first major incidences of a wide-scale attack was the Saudi Aramco oil company. It is the largest oil company in the world, and in August of 2012, 30,000 machines, or about 3/4 of their workstations, were suddenly flattened. The data was erased, and many of the indicators that were present after this attack were not the hallmarks of a sophisticated attacker that had been in the game a long time. You literally left a Pink Panther-esque business card that was this flaming American flag image. That's the opposite of a mature attack. So what was then found is that losing our slide here. What was found in the subsequent analysis is that there were stolen credentials that were used, that were present across the domain that could be used to extend that attacker's reach. The director of security, the U.S. Department of Defense at the time, Leon Panetta, had described this as a significant escalation in the cyber threat. In fact, this event is a lot of the reason that today terms like cyber terrorism, cyber warfare, those are now in the public parlance, sadly. So Richard Clark, who was a former counterterrorism official at the time in the National Security Council, summarized this whole event as it showed that you didn't need to be sophisticated to do a lot of damage. January 30th of 2013, the world found what a sophisticated attacker could and had done with this same weapon. The New York Times published that they had found that for several months, their entire infrastructure was compromised. All of their user credentials and all of their data was accessible to an external entity, believed to be tracked to the country of China. A day later, the Wall Street Journal published the same information for their organization. In the months that followed, several other organizations came forward and indicated that they had been attacked in the same manner. And what was then found is that the Mandiant organization, who makes, they consult with companies to help remediate and respond to these type of attacks, indicated more publicly what they had known, that since around 2004, these attacks had been performed by what was strongly believed to be a military-backed organization against over 110 different U.S. institutions. The field that is targeted changes depending on the national interest, but the technique is the same. You spearfish or compromise one low-level employee, collect credentials, expand, repeat until you own the enterprise. At that point, you can be dormant and present for months or even years, at which point you're siphoning data, selecting what you want, and sending it off-site to process. Most recent large-scale attack that is in, again, the public discourse is the Target breach. This, as of the last week, in fact, culminated in the stepping down of the CEO. The target attack was active between November 27th and December 16th. If you know anything about Black Friday shopping season, that was a prime candidate, a prime window to target a major retailer. Every one of the nearly 2,000 retail establishments in North America was compromised with malware. Of course, analysis that followed found that pass the hash was used to get to one central server and from there exfiltrate that malware to every point of sale system. No one person traversed every 2,000 Target stores. The interesting thing here is that the machine that was initially compromised, the initial point of attack, wasn't even a Target machine. It was a vendor contracted for HVAC work by Target. That machine had line of sight to the Target Active Directory infrastructure. Once the attacker made that hop, they could then spread and infect the entire infrastructure. Target is not the only major retailer that has been affected by this ever, or even since. There have been several that are lower scale. The unique thing about Target is the fact that because of the volume of customers, 110 million customers were affected. 40 million credit cards were known to have been stolen in this attack. That's enough credit cards that if you were to lay them on the floor, if you've been to the gargantuan expo floor on the first floor, you could cover the entire floor 3 times with stolen credit cards from this Target breach. The pass the hash attack, regardless of the ecosystem, the environment, the field you're in, if you're targeted, it means that any one leaf node, one bad click is the first domino that brings everything down. These examples also show the myriad reasons why people do these. The tools that are used are sometimes for philosophies, sometimes for politics or patriotism, sometimes even for profit. At least one of these tools was built for none of these reasons.
Yeah, so how many people are familiar with PSExec? So for those of you that aren't, PSExec is a sysinternals tool I wrote a long time ago. I've been updating it since, but it allows you to execute commands on a remote system as if they were local. It's kind of the poor man's SSH for Windows. And it leverages, if you don't specify a password and username to authenticate to that remote system, it leverages the credentials of your credential verifiers of your current session to authenticate to the admin dollar share of the remote system. What happens is that attackers love this kind of technique to spread through the local admin share and other admin shares on systems. They get their foothold on the machine, they get the creds, they get the session, and then they use those credential verifiers to go authenticating to admin share, and then they want to drop their malware on that admin share and then activate it. And using PSExec is a fantastic way, an easy way, to activate malware on a remote system. And so I occasionally get emails from disturbed users of PSExec, or actually inadvertent users of PSExec, like this one right here, who says, I'd like to share a case with you. We're actively owned in our company, and we see PSExec being used by the attacker to spread from machine to machine, and we can't get a handle on this thing. Is there a group policy, some other setting that we can use to turn off PSExec? And I always apologize to people like this, and I tell them there's really nothing I can do. At least that's what I've set up to now, that there's no way that I can really stop PSExec from operating in this way, but through malicious use. But earlier this year, I took action, and I think I've got this problem under control for everybody. Has anybody been attacked with PSExec in their network? So I see a few hands going up. Well, fear no more. I've added this to the EULA. And so that problem is fixed. All right.
That's the talk. So returning to the example that Mark had showed earlier, Sue, administrative Sue, who is domain administrator using her laptop. We're going to look at greater detail at what goes on in the Windows internals, because shortly we're going to be showing a stage demo of this attack being performed, the type of pass the hash that we can do legally in the state of Texas. So when Sue provides her username and password, what happens is this is fed to a process that is responsible for producing the single sign-on for Sue's experience, the local security authority. This LSASS process is going to ready the machine for single sign-on. LSASS hosts a number of plugins. We've given 3 examples here, each of which represents a protocol that Windows supports. These are either their native inbox ones, of which these are 3. You can also add others. There are software packages that add more. And so what happens at sign-in is that Sue's raw credentials, her username and her password, is presented to each one of these protocols so it can ready the device for single sign-on. It can prepare whatever credential verifier it needs to do so. So for NTLM, it takes that password and it produces the NT one-way function hash, or NTLM hash, and keeps that in memory. The digest protocol, when it supported single sign-on, which it did up until very recently, in fact, in order to do single sign-on and digest, because the protocol was not with the modern conveniences that we have in today's protocols, it needed to keep a plain text password around to support single sign-on. Kerberos as well would take the password, it would authenticate to a domain controller, it would get a ticket granting ticket, or a TGT, and then also a collection of service tickets. This set of credentials would then be held onto, and for the duration of Sue's user session, to facilitate single sign-on. What then would happen is that the password can now be dropped because we don't need it anymore. These credentials are there. Imagine Sue then accesses this machine, PTH-demo-DC, the domain controller. The local security authority is asked if it can authenticate without asking Sue directly because we don't want to unnecessarily prompt for credentials. Kerberos says, I can do that. I have a service ticket. I'm able to authenticate to the domain controller. It is presented, and now Sue is able to access her resources without needing to type in her creds. Imagining that later then, Sue accesses the same machine via an IP address, 192.168.1.1. Kerberos does not support IP address-based targeting, so Kerberos says, I can't do this. NTLM, however, is able to authenticate to an IP address. NTLM will provide the hash, and again, Sue is able to access the share. What this example shows is the reason that single sign-on is not an oversight or a design defect. It is desirable that Sue is not being asked every time she accesses her SharePoint, her email, her company benefits portal, who she is, and to prove it. But additionally, the reason that all of these different protocols are supported throughout anyone's user session, you're switching between a number of protocols, and the user couldn't or shouldn't be required to know which protocol is used in each situation. This is the reason we have this LSASS Swiss Army knife of protocols available. A term that we use to describe this credential residue that is kept, the collection of credential verifiers for the duration that Sue is using the computer, is called the credential footprint. We'll talk about that later as we go through some of these examples of the changes that have recently been put in Windows. So the fact that this is what a computer does literally every day didn't change the fact from it was eventually discovered in the wild and deemed a threat. And so in 1997, Paul Ashton, producing a SMB client, found, to his horror, that you could use not the password, but just the NTLM hash in order to authenticate as a user. And it was put in the tool as a proof of concept that this could be done. This was, again, no surprise to anyone that worked on Windows. This is what your machine does every time you use NTLM to authenticate to another resource. But the fact that the password wasn't directly being used triggered alarms and concerns. This is, in fact, the reason that this talk is titled Pass the Hash and not Pass the Ticket, Pass the Password, Pass the Smoke Signal, because this was the first discovery. 11 years later, in 2008, it was also discovered that, lo and behold, I can steal a ticket and perform the same attack. What's happening in either of these cases is an attacker gets administrative access to a box that, in the prior example, Sue is using, and steals and does a credential theft attack to harvest those credentials. It's a law of physics that if that credential footprint represents you, and that's all the machine needs to be you on the network, any attacker that has that credential footprint is also you. That is unavoidable. And so, in fact, any protocol that you go down the line that's an inbox Windows protocol will support this same type of pass the star attack. And if you want some quick notoriety, I invite you to go to a website like this and log pass the PKU2U. Pass the digest will no longer work, unfortunately, so we did close that one off. But no one has yet taken me up on my offer to pass the PKU2U. So what had been done by Microsoft is that there was a proliferation of bad data. And we wanted to try and educate a little bit and bring people the knowledge of what you know based on the talk thus far, that this wasn't in itself an attack, it is just explaining and understanding how single sign-on works. So Microsoft had published a document in December of 2012. There is a new one forthcoming imminently. You'll have it this summer that'll take into effect the things that we're talking about. And the main intent of this document was to sort of level set the expectations and understanding of what pass the hash is. The problem is not NTLM or any one protocol. If any two machines can speak NTLM, Kerberos, digest, PKU2U, secret handshake, carrier pigeon, if they support single sign-on, it is a vector for this attack. And so customers had spent a lot of time and money eradicating NTLM and then found that Kerberos was also susceptible. Everyone in the room, please take away that it is not an NTLM problem, and the name pass the hash is more of a common parlance because of its history than it is a description of the actual attack. Another surprise to many was the fact that a smart card authentication actually doesn't defend you against pass the hash. Enforcing and requiring smart cards is a terrific way to bind authentication to a physical device. I can give you my password, I can tell it to you on the phone, I can't give you my smart card. However, if I steal your ticket that represents a smart card login, as far as anyone knows, I now have that smart card. If that ticket represents a phone call with the president, an SMS code you received, any one of those is encapsulated in that ticket, and if the bad guy gets that ticket, he can claim that same proof. So the way that this attack works and the way that we'll demonstrate, here again is Sue using her computer. She has her credential footprint active, and unbeknownst to her, Fred, or his malware, has infected the machine with a tool that is going to be used to harvest credentials. Here we're going to show Amplia's Windows Credentials Editor. This is a tool, if any of you want to play with it, you can download it from the Amplia Security website. And it is used by pen testers and attackers alike. And the clever trick it can do is it knows how to parse the internal data structures in the local security authority to find the hashes and credential footprint, to make sense of them, and it can both extract them and feed them into a store. This is the credential theft attack. And in addition to that, you can take previously harvested credentials and use them to overwrite your active user session, meaning that when you go out, you now masquerade as a different person whose credential you stole previously. Because of this trick, I can use the Windows Credential Editor to steal someone else's identity while they're using a machine, and then inject that identity into my own session. Instead of taking my word for it, we'll show you this now. So we are going to start. We have a sample domain set up with a number of...
Actually, that's not the right one.
Thank you. x86?
Member server.
Yeah. Thank you. So we have a Windows 7 machine that we're going to use to demonstrate the environment prior to these technologies, because as of yet, they've shipped to Windows 8.1 and Windows 2012 R2. And so here is Sue using her currently Windows 7-based laptop. So Sue starts her device. She has, again, remember, these administrative credentials that she's going to use to do her work. And so she's going to log in. She is not suspicious to the fact that Fred was apparently using her laptop last. So inexplicably, that passes her attention. And so in her day, she opens a share just like you do. And on it, she accesses another share that is ACLed to Sue only. And in here is super secret information that Sue wants no one else to see. We had removed the slide that said no photography, and now there goes my money. So unbeknownst to Sue, however, Fred is active running malware on this machine at this time. And so this command session is going to simulate Fred and the things he's using. We're doing it in a command shell so that you can see what's happening. So this tool is the Windows Credential Editor. And what it can do is attach itself to the local security authority and dump out the credentials that are active in the machine. You can see here Sue's hash. Similarly, we're going to capture Sue's Kerberos tickets. Sue, of course, was not aware of any of this. And so she's finished using her machine. She logs off. So now Fred, knowing that he had planted this malware, returns to the machine to see if he had harvested any credentials. So Fred, of course, because he forgets who he is, he starts by accessing the Sue-only share, and oh, he can't access it. That's right. But he had that malware running. See what he found. So first, going to attempt this to show there are no tricks up my sleeve. You can see that Fred, on his own, cannot access the share. However, Fred captured Sue's Kerberos tickets. So what now can be done? He injects the tickets into his session, and now he has access via Kerberos. And if you remember the earlier demo, what happened here is that we forced NTLM by accessing via IP address. I don't have, at this time, Sue's NTLM hash, ergo I don't have access. But again, Fred was able to capture her hash as well. He's going to inject that into his session. And now he's able to access it via NTLM as well. Now seen pass the hash in action.
So let's start talking about some of the mitigations. So you've seen pass the hash, you understand the problem, you understand the way that it works on Windows with the Windows architecture and credential management storage. Let's talk about the first set of mitigations, which are aimed at local accounts. The challenge with local accounts is that many organizations use the same local account username and password combination across multiple machines in their network, sometimes even for every machine in the network. And that might be inadvertent because you've got a common base image that you go and deploy to your systems, and so they all end up with the same account, local account and password on them. Or it might be deliberate because you use local account authentication to troubleshoot problems where the system might not be accessible using a domain account because maybe the domain controller is inaccessible. How many people use that, local accounts in that context? How many people don't use local accounts at all in your network? How many people don't have a network? All right, so let's talk about now the way that this attack works, and that is simply that the hash for the local account password is stored in the SAM database, the Local Security Accounts Manager database on the system, which is part of the registry. Attacker, like one using WCE, Windows Credential Editor, grabs that out and then can authenticate to Sue's laptop using the local account, using NTLM, LAN authentication protocol, to talk directly to Sue's machine, not talk to Kerberos, talk directly there. And the authentication protocol is such that if the same account username exists in the Local Security Accounts Manager database on both systems, and the system that's accessing the target can prove that it knows the same password for the local account on the target system, that it's considered the same account on the network and is allowed to authenticate remotely by default. So this is what gives you by default the ability, if you've got a local admin password, to go accessing the admin shares on other systems with just using that local account password and username, or username and password, as long as the other machines have the same combination in place. And so this is really one of the most common ways that attackers use NTLM, is not to take advantage of domain accounts, but actually just to spread using NTLM for local accounts that have the same kind of password on them. So let's take a look at the first mitigation, which is if you're in a networked environment, if the machines are part of the domain, you really shouldn't be using local accounts to go talking across the network to other machines. When you want to come across the network, you use domain accounts to authenticate to the machine. And if you need to work on a box when you don't have domain account access to the box for some reason, physical access is what we recommend in that scenario. So this first mitigation is aimed at letting you control access of local accounts across the network, even in the case where you might have inadvertently or deliberately have the same local account passwords on all those machines. One of the most effective things, uses of this is you can still use the same local account password on all your machines so that you can go and physically access the machine, log in with that password that you know, yet somebody compromising that box can't use that password to go traversing across your network, compromising the rest of the boxes with that same password on them. Let's take a look at this in action. I'm going to log into this machine. Server 1 and Server 2 are both members of the domain, but I'm going to be logging in with the local administrator's password to both of them. And the reason I'm going to do both of them is because we're going to lock this vector down after I show you it in action. They both have the same exact password. And now what I'll do is I can do server 2 $. And I'm doing that even though these are domain joined systems, logging in with the local admin password account because I've got the same admin password for the local admin account on server 2. A couple things that are allowed to mitigate this. One is that there's always been in the security policy editor a way to prevent logons from the system for specific accounts. So I'm going to launch SecPol, the local security policy editor, and if I go to local policies, user rights assignments, there's this deny access to computers from the network here. And this has always been there to be able to say, don't let these specific users or groups access this machine over the network. And this is a way to keep those guys off this box, even if they might otherwise be authorized to. The trick here is how do we make it so that any local account, whether it's the local administrator's account or a local FRED account that has local administrative rights on, on another box, can't access this machine from the network. And that's been very hard to do up until this mitigation that I'm going to show you because there's been no way to consistently just say no local accounts should be able to access this machine across the network. To enable that kind of policy, we've introduced two well-known groups. So I'm going to fire up another tool. Oh, actually, I'll do it on this machine. Oh, it's already running. Process Explorer. If I go to explorer.exe and I took a look at the security tab, this shows me the groups and users that are part of the token that Explorer is running under. And on Windows 8.1 and Server 2012 R2, the system injects two new well-known groups. You can see they're right here, NT Local Authority and NT Local Authority Local Account and NT Authority Local Account and Member of Administrators Group. So you can target one or the other. The blanket way to target any local account is just to target local accounts because local administrators will obviously be a member of that as well. And that's what we're going to do on this box is prevent access from another system for, and I actually have to change the target location, not to the domain, but the local machine. And this is where you're going to see a bunch of prompts of Windows, I think, trying to harvest my credentials. Because it's going to, and I can just say escape and say server 2. Now I can type in local account. And then it's going to try to harvest my credentials again. Just resist, escape. It's going to try again, it's persistent, escape. It's going to try again, be persistent. It's getting harder now though. Escape. It's going to try yet again. Maybe this is the last time. Escape. No, one more time. One more. There. Okay. So that's Nathan's bug. And there's a local account. So I'm going to select local account now. Whew, that was tiring. Now I'm going to try this dir again. And I still can access that machine. Why can I still access that machine even though I just said deny local accounts from remote access to that machine? Does anybody know? GP update? No, that's not it. Anybody else? Session. Somebody said, yeah, somebody got it. Watch, if I do net sessions on this machine, there's an active session from server 1 to server 2 that can still be reused as long as it's active. No need to re-authenticate. So no, it won't run into that policy. So the way you can deal with this is net session 192, 168, 101, 11, delete. Say yes, and now I get logon failure. The user has not been granted the requested logon type at this computer. And so that way I've just stopped that spread of those local accounts through the system. So let's turn it back over to Nathan, who's going to talk about the next local account mitigation, or actually first domain account mitigation.
Hey, thank you. So in addition to local accounts, how many of your networks use domain accounts? Hopefully every hand, right? So domain accounts are another mainstay. They are the way that you intend to communicate from one machine to another. And this is often the target of the tools like what we showed, the Windows credential editor, and what we'll now introduce is Mimikatz. Is this a term that anyone has heard before? Mimikatz. Oh, wow, okay. You are the right audience. So Mimikatz is comparable to Windows credential editor, other than it has the world's most obtuse command line. And also, it supports Windows 8.1. Ergo, we're going to use it from here on out. And so Mimikatz, just like Windows credential editor, is capable, it's extremely full-featured. It's able to pull apart all of the credential residue in the local security authority and place it into a credential store. And you'll see how exhaustive that is shortly.
The thing about Mimikatz I think is interesting is it's written by a Frenchman.
Right.
And most people that write tools for Windows, they write their tools in English, because that's kind of the universal IT language, but he's French, so he says, it's in French and deal with it. C'est la vie. So that's what makes it extra hard to use if you don't know French. Just FYI.
Yes, and what we'll see, we wrapped it in a batch file to prevent typos. So what now has happened is he conveniently made for us, when we released the first preview of Windows 8.1, a chart that he had put together of the credentials he saw going away. We were in the process of doing this work that we're about to demonstrate and put together this terrific chart. And so as an homage, this is a preview from the new Pass the Hash document that's going to be coming out shortly, where we have taken and extended that same table. So one of the first things that was done is that we targeted a lot of this credential residue. All of it had a job. It wasn't as though it was an oversight. But we felt that the threat of credential theft and reuse exceeded the value of some of these scenarios for which these used to be there. One example here that might be a surprise, you can see plain text equivalent passwords as a scenario, and wdigest or TS package. That sounds alarming. The digest protocol, if that were ever to be used as a single sign-on protocol between two devices, needed a plain text password in order to function. That was just the design of the protocol. Similarly, Kerberos would hold on to your password because changing certain group policies requires going back to the password. If we change your authenticator key, we need to go back to the password to calculate your new Kerberos authenticator. That was kept in memory for the sake of reducing reboots. This is a noble goal, but in the light of the Pass the Hash attack, we felt that the interest was no longer there in reducing reboots if it meant increased exposure to Pass the Hash. Ergo, we got real aggressive with removing these credentials. Similarly, session expiry, as you log off, the session itself that we've shown in these slides as a ref counted object, any stale reference to it would keep that credential handle available indefinitely. So your NTLM hash you believe is wiped because you logged off yesterday is still there when Fred accesses the machine and performs his attack. In addition to this, there's a protected users RID, which we'll walk through, and hardening the LSASS process. So returning to these machines, I'm going to sign off with local administrators because we're now going to perform these attacks using domain credentials and show how they're better in Windows 8.1 and soon to be downleveled. So we're logging in as the administrative user Sue. And you can see here, let's say again, she has as bad luck with her laptop as she did beforehand, and Fred once again has malware running on the device. And so what we're going to do, again, this is to show you that I wasn't making it up. The typos make it extra difficult. So we're going to dump the passwords. And if we look it up, what we'll see here is that Sue, here are her credentials that were found by the Mimikatz tool. On a Windows 7 device, there would be a plain text password here for digest SSO. Similarly, there would be a plain text password here in the Kerberos protocol, and there would be one in TS package as well. All of those are gone now thanks to the credential footprint reduction. Furthermore, there is an opportunity to run the local security authority as something called a protected process. Now, I'm going to do this in a shorthand way. There's a better way to do it that I'll talk to as we reboot the machine, because it requires a reboot to take effect. What I'm doing now is I'm setting, there's a registry key called run as PPL test. I'm setting it to 1. What this will tell Windows is to run the local security authority as a protected process. So while the machine reboots, I'll describe what that does. Protected process is a system facility that was put in since Vista that was there for basically hardening a process to require code signing on every binary that runs. And so what now is supported as of Windows 8.1 and 2012 R2 is that you can run the local security authority process as a protected process. One of the challenges there is that that configuration, as I set it in a registry key, since your threat vector is an admin is trying to do bad things, the correct way to set it is a UEFI secure variable that will write itself to your machine and be incapable of being removed without a physically present user running a special tool that requires you to boot from a thumb drive. It is intentionally onerous because you want to pick something that the attacker from some far-off country can never do. So what now happens, though, we can see that, again, Sue is logged in. Now her local security authority is running as a protected process. And if, again, Fred attempts to dump the passwords, what we see happens is it attempts to grab the handle and open the LSA, and it gets error 5. Anyone familiar with what error 5 means? The NT? Access denied, that's right. So basically, because the Mimikatz code is not signed properly, it is incapable of accessing the local security authority. Nothing can be harvested. Now note that setting this also requires that any of the good things that run an LSA that you desire, like your smart card driver, will need to also be signed. There is a facility to get components signed and software packages, and there's a way even to try this and test it to see which of your components, if any, might not support that signature. Everything in box in Windows will run that the local security authority is designed to run. So the other thing we'll do is we wish to constrain single sign-on further through using something called a protected user. A protected user is a means to take a user and say that we're going to restrict their single sign-on such that it's bounded only to a very limited period of time. We're going to add a user. This is just a group that is it's a well-known RID that is present in any up-level domain that is called the protected users group. And I'm going to add someone called protected Sue to this machine. So now what we see when we log in via server 2 as protected Sue, that the machine is going to behave differently. What's going to happen is that any credential that would be a long-lived credential, for example, your NTLM hash, which is unchanged until you change your password, is discarded. It is not held onto, in order that even if Sue now uses a device that's untrustworthy, the longest-lived credential that an attacker can harvest and use is a Kerberos ticket. Protected users also restrict the default to 4 hours, and again, that's configurable. And the retirement of your creds that are in memory after you log on is more aggressive. We basically cranked everything up with protected users to ensure that you don't leave any residue for anyone that has this extra sensitive credential. And to show you how this works, we're going to do the same thing we've been doing to show you that you can still access files. She can still do her job, but yet if anything forces NTLM, like doing the IP address targeting, it will not work. And again, imagining that Fred is present and he's attempting to use Mimikatz, the difference between before and now is that the NTLM hash isn't present. Interestingly, the Mimikatz tool seems to have some kind of a vulnerability where it buffer overflows and reads for quite some time. Eventually, it'll give the opportunity to record a bug to be passed to Mr. Mimikatz.
And we're still working on the exploit for this, but we'll be posting it soon.
So, okay. And from this, we've now shown the reduced credential footprint and domain accounts.
Okay, so one of the scenarios that we've seen actually customers run into, a very tricky way that attackers manage to get powerful credentials to start their traversing through the network. This came to us from the GSA, which is the Government Services Auditing or something. I can't remember what that stands for. Anybody remember what that stands for, GSA? That's it, Government Services Administration. They're the guys that do audits or that approve audits and use of certain vendors for government purposes. And so they came and looked at Azure, for example. And when we were talking to them about the pass-the-hash problem, they said, yeah, we see actually as we go and look at government organizations that pass-the-hash is rampant. And one of the common techniques we've started to notice in these organizations for the way that attackers get in and start to leverage pass-the-hash is this right here. They'll compromise using a spearfish a low-level lobby receptionist. So somebody that's not very sophisticated, doesn't really understand cybersecurity, is actually considered a low risk by the organization. So they're not really that concerned with that person's ability to compromise the network because they really don't have any privileges anywhere. But what the attacker does once they've compromised that person is put some malware on the box, on the user's box, and have that malware start to screw the machine up. So they'll have it run slow, and then they'll have it Windows closing randomly, and they'll have the keyboard misfire. And this is just a kind of a low-level annoyance, enough that eventually the receptionist decides that they can't live with this any longer, and they need the help desk to fix the problem with the sysinternals tools. And so they call the help desk. And the help desk, what does the help desk do to fix a problem like this? They RDP to the box. Now, when you RDP to the box, you're not just using a standard kind of authentication. Of course, you do initially to RDP to the box, but you're actually presenting your password as you type it into the RDP client to that target system to create an interactive logon session as if you logged into the box interactively, where you do type in your password to that session. So Sue's password here goes right to that target machine and authenticates to it. And now all of Sue's credentials are stored in that machine. Credential verifiers are stored in that machine as if Sue had logged in locally. If this is the help desk now, the help desk credentials are sitting on that machine. The bad guys already compromised it, and now the bad guy harvests the help desk credentials. And the help desk credentials are among the most powerful in the network because they need powerful credentials to go and fix all the problems that they're fixing. So we introduced a switch on RDP to prevent this attack from happening, and targeted specifically at these help desk scenarios that can be a little more restrictive than your standard remote desktop access. And that is a switch called restricted admin. With restricted admin, instead of passing your password and authenticating fully interactively, it essentially uses a Kerberos authentication to this remote system. And with Kerberos, you never actually present credentials to the target system. You present a proof of the credential in the form of a service ticket to that remote system. It's what I call Kerberized RDP. And with Kerberized RDP now, the only question that remains is, what kind of footprint do you have on that target system? Who do you look like if you haven't actually passed your password? And I'm going to show you what that answer to that is in a second. But let's take a look at this attack in action here. Actually, did you reboot this server? No.
I rebooted server 2.
The PPL one is.
So yeah, right.
So let me reboot this one. -RT0. All right. So let me get server 2 ready to go. And I'm going to log in as Fred, our bad guy. And Fred is going to be sitting on that machine, having infected it with malware and trying to lure the help desk, who will use Sue as the help desk, to come over and take a look at the problem. So let me get Fred ready here. And now Fred's ready. Let's RDP in the standard way that would happen. In this case, Sue's going to enter her password. And now with the RDP protocol, that password's going right over into server 2, and the credential verifiers are going to be stored there in a second. This will just take a second, and when that happens, we're going to dump the passwords, or dump what Mimikat sees as this in-memory stored credentials. Oops. And there we go. And at this point, if I go take a look, we're going to find Sue right here. It's a remote interactive session, and you can see Sue's the username here. Domain PTH demo, here's the NTLM hash. Here's the Sue digest plain text password, or actually it's emitted by default now, but we would have seen that on a down level system. And then we see that the Kerberos ticket is sitting here for Sue to access to PTH domain. So now Fred has captured the domain, the help desk domain credentials, the ticket, the NTLM hash, and now can go spreading across the rest of the system with all the privileges of the help desk. So let me sign out now and use the restricted admin option. So with this, MSTSC. And you'll notice that I don't have to enter a password. That's just because it's using the Kerberos ticket granting ticket to go request a service ticket from the domain controller and then authenticate to server 2. This would be the same kind of authentication if I just accessed the file share. But we're going to have an interactive desktop. And then when we do get that interactive desktop, I'm going to dump what Mimikat sees stored in the local security accounts manager and see what kind of user Sue looks like here. And so you can see interactive session for server 3, but notice something different here. Before where we saw username Sue, now we see username server $2. Server $2 is the computer account in the Active Directory domain for server 2. So now, even though Sue logged in here, it looks like Sue. When it comes to going across the network, it's not Sue. It's the computer, server 2. And so that keeps, as long as you haven't ACLed things such that server 2 can go amok on the network. Now Sue, the help desk administrator, is sitting there, has local admin rights, is able to troubleshoot the system, has never exposed credentials to that target system, and cannot even go off the box as Sue, except as the local computer account, which you might want Sue to be able to do. For example, you might want to ACL a file share to say, computer accounts, members of a certain OU, can access the share to get tools off it, for example. So a way to troubleshoot things, or to dump log files onto it for later analysis and things like that. But now this system is protected. The help desk account is left out of harm's way. So let me reboot this machine to get ready for the next demo, because we're going to take it up a notch and go to something that's a little bit more onerous, a mitigation that's a little bit more onerous to put in place, but is one that you want to take advantage of for your very high value assets. And that is something we call authentication policies and silos. And so the issue here is that we don't want unprivileged users to be accessing privileged systems. Conversely, we don't want privileged users to be accessing unprivileged systems. Either one of those combinations is obviously bad, especially the privileged ones accessing unprivileged systems, because those are the ones that might get compromised. The privileged user using an unprivileged system, surfing the web, doing email, getting spearphished, and then using that system to go and access the privileged user. So this is Fred. This is lobby kiosk. This is the replay of the lobby kiosk getting, well, this is a lobby kiosk actually. So here, let me set up the scenario. Sue's the IT admin. Sue can authenticate to the domain controller. What we don't want is the lobby kiosk to authenticate to the domain controller, even as Sue, even if they've got Sue's credentials, and we don't want the IT Sue to be able to access the lobby kiosk machine because that's where the malware might be, as it was in our previous example. So the authentication policies and silos that I'm going to talk about allow you to create these bastions of high-value assets that include both the computers, the systems, the servers, as well as the users that access those servers, and you want to put them all together. You don't want your domain admin to be sitting outside of this thing with the domain controllers inside. The domain admin sitting out in unprivileged stuff in the wild west of the world and the domain controller being inside. The analogy that I've come up with to explain authentication policies and silos is kind of like you got the small town. Your network's like a town. Now there's some central services in your town that are the machinery. They help the whole society operate. One is the bank. The bank has the money. The other one's the DMV. The DMV eventually gives out driver's licenses to people when they go and wait in line for a long time. But if those get compromised, then you can mint identities for anybody. And you can also create money. You give out money to people that aren't authorized to use it. So what you want are the people that work at the bank to stay in the bank with their keys to the bank. You want the people in the DMV to not take their DMV keys home with them. You want them only to use those keys to actually walk into the DMV and unlock it. So, because if they take it home and then they get robbed at their house, then somebody's got the keys to the DMV and can go start minting identities. Same thing in your network with the domain controllers, your Exchange server, your systems management servers, and the fleet of system workstations where your users operate. And so, look at your network topology, identify those high-value assets, and what we recommend is start simple, start with just your domain controllers, then go for Exchange servers and work your way out. But start small, at least protect your domain controllers, because once those are owned, it's really, at that point, very hard to get your systems back. Now, what this shows right here is that to do this, you create both an authentication policy, which is permissions on the Kerberos ticket lifetime and who's bound to this policy, and then authentication policy silo, which are the resources that policy is bound to. And so this is, for example, the machine. So only Sue can log into Sue's machine. Because Sue's the banker, Sue's bank credentials should only be presented to that Sue's bank machine. Somebody else from another system presenting Sue's credentials, the banker's credentials to the banking machine, can't get access once you put it in an authentication policy with the silo. So authentication policy connected with silos, and then you add users to the silo and machines to the silos is the way that you construct this. So it's a little bit complicated, and you're going to see me walk through the UX to construct this system. And what I'm going to do in this example is set up an authentication policy such that Sue's, protected Sue's, Kerberos tickets last only 1 hour. That way, if somebody does manage to somehow get a hold of one of her Kerberos tickets, it only lasts 1 hour, and if we roll over the password in that after that time, the Kerberos ticket is invalid. It can't be continued to be used, as opposed to the long lifetime Kerberos tickets you get by default. And we're going to make it so that Sue can only log in to server 1, no other machine on the network. So Sue is like the banker, and let's just pretend server 1's the bank. We want to keep Sue on server 1, and we want to get so Sue can't access any other machine, and nobody else can access server 1. So let's do that. Let's turn back, and I'm going to log into the domain controller to get this set up. The domain controller is right here. And we're going to be working down here in the Active Directory Administrative Center. There's a new area down here in Server 2012. Authentication with, you can see authentication policy silos and authentication policies. And the first thing we're going to do is create the policy. So I click the policy, I say new, authentication policy, and I'm going to give it a name, Sue policy, because this is going to target protected Sue. We're going to say enforce, I'm going to disable that. And then we're going to add protected Sue. And we're going to assign it to a silo here when the silo is ready. So it's not assigned to any silo at the moment. We're going to specify ticket granting ticket lifetime of 60 minutes, like I said. we're going to then, we're going to add a condition, which is that user authentication silo. This is going to apply to SU silo, which we haven't made yet. And so this is what I was referring to. You've got to make, because these things have to point at each other, one doesn't exist yet while we're configuring this one. So we're creating the policy. We're going to reference the silo we're going to make in a second to add this policy to. And then that's it. And so we'll say OK. Now the next step is to create the silo. And this is where we're going to be putting the machines and SU into the silo. We're going to call this SU silo. And the permitted accounts here, we've got protected SU is allowed to come into this silo, and server 1 is allowed to come into this silo. So those are the only two resources that are allowed to enter this silo. No other user can enter this silo. And these users are now contained within the silo. Now, which authentication policy do we want to assign to the silo? Well, we've created SU policy with that 60-minute Kerberos ticket lifetime that we want to apply to anybody entering this silo. And now we're ready to go. We say OK here. Now, a final step is we've said when we created up this silo that server 1 and protected SU can enter this silo. Basically, that is saying the silo allows those users, those resources to point at it. Now we actually have to go into users and computers to have those users now bound to the silo. And instead of opening the users and computers snap-in, which we could do, we can do it right from here. By going to users, going down to protected SU, right here. And then you can see down here there's silo. And we can say, let's put SU in that silo now. So this is the final step of connecting the policy, the silo, and those resources together. And the final one is the server 1. And we're going to put that in the silo as well. Now, the reason that we've got to do this multi-step thing and it just doesn't happen automatically is permissions. It's security. It is to prevent somebody from adding themselves to a silo when they're not authorized to. It's to prevent somebody taking themselves out of a silo when they're not authorized to, or assigning a policy to a silo when they're not authorized to. So that's why these are all discrete steps on different objects, is to make sure that the system can be kept secure and only unauthorized people are allowed to create these things, because they're very powerful and they can actually lock you out of your network if you mishandle them. So now we've got everything in place. And now the test is, I've got server 2 and server 1. Let's see if SU, protected SU, let's log her into server 1. And SU's able to log in to server 1. How about server 2 now, which is outside the policy, outside the silo?
Enforce thing on the DC.
Oh, yep. Actually, I've got one more step. This is another one of Nathan's bugs. He reminded me of. And that is, I've got to go back to the silo. And this button doesn't stick the first time you edit this thing. So you've got to, pro tip, reopen this thing and reset it. Right, Nathan?
Yeah, that's right.
Yeah.
I ship in the box with 2012 R2, so I just whisper that when you're configuring a silo. It works great.
All right.
We'll fix that bug.
Here we go. Let's see if everything works together. And if this happens, the banker, Sue, should not be able to walk into this. This might be her everyday workstation, her house, with her keys. And the answer is, your account is configured to prevent you from using this PC. Please try another PC. And so that has kept Sue's credentials off this box, or credential verifiers off this box, and attacker is not able to get at them. So this keeps Sue, protected Sue, from inadvertently walking home with the keys and then leaving them there on the counter for the bad guys to come and steal. So that brings us to the conclusion of the talk. And one of the questions that we have is, okay, that's great. So I've got to update my domain to Server 2012 R2 functional level and upgrade all my member systems to Server 2012 R2 or Windows 8 1. Really?
No. So there's a backport underway.
You wanted to do that anyway, right? But it's going to take you a while.
Yeah,
so in the meantime.
Please do. It's a great OS. You'll love it. But for those of you that are still using Windows 7, Several of these are going back literally as far as they can. So the local account well-known groups that Mark had demonstrated, those will be available to Windows 7. The reduced credential footprint as well is moving down. The RDP client restricted administrator is also, again, going down level as well. And finally, the enforcement of protected users is something that the client will recognize protected user membership. It's important to note, this is where it gets nuanced, the protected user well-known RID is only going to happen at the up-level DFL, but if you still have a Windows 7 client, it's going to know how to respect that and do all the right things.
So that wraps up the presentation. So let's talk about what we covered. We talked about pass the hash, how it's really not a Windows issue specifically. It's a single sign-on issue. We talked about some of the tools that the hackers use and the techniques of credential harvesting with these tools like WCE or Mimikatz, or what we see most often, sophisticated attackers have rolled their own versions of these tools so that they can fly under the radar of anti-malware. And then we take a look at some of the mitigations, including the local account mitigation for well-known local groups of local user and local administrative user. We took a look at protected user, which scrubs NTLM credentials, also reduces ticket lifetimes. We took a look at RDP, restricted access. We looked at PPL, which is locking down LSASS to make it harder for those kinds of tools to work. And then we took a look at, finally, silos and authentication policies to create those neighborhoods in your town that stop people from crossing the boundaries of the neighborhood with their keys and letting their keys get exposed to attackers. So the bottom line, I think the number one thing to take away from this talk is that PTH is a solved problem. It's fixed. And
we did it.
No, it's just not fixed. It's something that you got to work at. But we recommend that you go back, again, start simple, start with your domain controllers, and go from there. So with that, I want to thank you very much. I'm giving this is Nathan's last session, but I'm giving a few more. I'm giving 2 tomorrow on public cloud security, so back to cloud talking. I'm giving one with Mark Manassi tomorrow, me and Mark Manassi, in a discussion about cloud security and how IT pros are really screwed. No, I'm just kidding. Then we're giving a talk in the afternoon, I'm giving a talk in the afternoon about public cloud security and hostile multi-tenancy, a new kind of concept that comes with public cloud. Thursday, I'm back to Windows and on-premises stuff with malware hunting with the system internals tools in the morning, and then Casey Unexplained in the afternoon. Like I said, I'm doing some book signings too, so I hope to see you. Hope you have a great week, and thank you very much. Now the malware presents itself as Sue to that system, and now the whole network is owned at that point through this lateral movement, collection of, or harvesting of hashes, and now ultimate owning of the whole domain. In fact, when we talk to Microsoft Consulting Services and they get called out for breach incident response at corporate environments, I would estimate, I don't know what the exact percentage is, but the 99% of the cases where the domain has been owned, it has been owned through this exact technique of lateral movement through pass the hash. So this is a huge, huge problem. Small companies, big companies, military organizations, government organizations, giant EU organizations we know that have had their whole domain taken over using this technique. So now Nathan's going to talk about Windows and pass the hash.
Thank you. I know what you're thinking. Beard, glasses, computer guy? I'm fulfilling the quota for the stereotypical computer dude. So as Mark had indicated, I'm a developer. I'm a dev manager in Windows. I'm responsible for authentication and single sign-on in Windows. So we've spent quite a bit of time working on pass the hash. And in this audience, many hands raised, many people are familiar with what it is. Sadly, pass the hash is no longer something that is just in parlance in industry circles like this. Its effects are actually felt across the world. One of the first major incidences of a wide-scale attack was the Saudi Aramco oil company. It is the largest oil company in the world, and in August of 2012, 30,000 machines, or about 3/4 of their workstations, were suddenly flattened. The data was erased, and many of the indicators that were present after this attack were not the hallmarks of a sophisticated attacker that had been in the game a long time. You literally left a Pink Panther-esque business card that was this flaming American flag image. That's the opposite of a mature attack. So what was then found is that losing our slide here. What was found in the subsequent analysis is that there were stolen credentials that were used, that were present across the domain that could be used to extend that attacker's reach. The director of security, the U.S. Department of Defense at the time, Leon Panetta, had described this as a significant escalation.
I feel like it's time.
Yeah, watching that clock. Oh, and we're on the clock.
All right. And we're off. It's a good one, isn't it?
That's right. See you next year.
All right, welcome to Pass the Hash, how attackers spread and how to stop them. My name is Mark Krasinovich, and this is
Nathan Ide.
And I'm a technical fellow in the Azure group at Microsoft. Nathan is a dev manager in the Windows security team.
That's right.
The reason that we're presenting this together is people are sick of me giving cloud talks, and so I just said, Nathan, let me give a talk with you that's not a cloud talk. How many people are sick of cloud talks? Yeah. All right. So it makes me so sad. But this is not a cloud talk. This is an on-premises talk, as we call it in the business. And the reason that we're working together on this talk is that leading into the development of Windows 8.1, we were focused in Azure at getting compliance, under control compliance for our infrastructure that accesses Azure production, as well as Azure production itself. And as auditors were coming through, we started to realize that, as they pointed out, and we realized, that pass the hash is a significant problem on any kind of Windows network. And there were places where we'd not properly prevented the spread of pass the hash. And we'll explain what pass the hash is in a second. So what I did is I sat down with a few other people at Microsoft, including Nathan and others in Azure and Windows security and actually the field as well, to brainstorm how could we help people get a handle on pass the hash, not just for them, but also for us internally at Microsoft. And so we came up with a set of features that we're going to cover this afternoon that have made its way into the product and give you some new tools in the tool chest for stopping pass the hash spreading throughout your network. How many people know what pass the hash is? So quite a few. How many of you showed up at the session like, pass the hash, I don't know what that is, but it sounds really fun? So, and actually I was going to say that pass the hash is a problem for many of you, but for some of the lucky ones, it is actually not a problem anymore. It's actually encouraged. If you've got the hash, you're encouraged to pass the hash. So, but for the rest of you, and actually Nathan and I do happen to live in Washington, so this is really awesome guidance for all of you that don't. So let me talk about pass the hash. Pass the hash has this reputation of, that's the Windows problem. Windows has this problem. It's pass the hash. And man, hackers just love taking advantage of pass the hash, and then they own the whole network just boom like that because of the sucky Windows pass the hash problem. In fact, this is a misconception, a fundamental one, about what pass the hash is and its relationship to Windows. Pass the hash equals single sign-on. Any system that supports single sign-on is susceptible to a pass the hash attack. And I'll cover exactly what pass the hash attack is in a second, but basically it is somebody uses credentials to log onto a system, and then some form of that credential or the actual credential allows them to go and access other resources without having to retype or re-enter their initial credentials. That capability is really powerful. Our end users love it, and we love it too. When you log into a system and then you go to the SharePoint site, not having to type in your password again. When you access a file share, not having to type your password again. When you print something to the printer, not having to type your password again. And that's the power of single sign-on. Otherwise, well, the only exception in the Microsoft world is Outlook, where you've got to type in your password all day long, 15 times a day. But that's Outlook, not Windows. But given that problem of having to retype in not type in your password, or that benefit of not having to type in your password, you end up with these credentials that an attacker, if they get on that box where those credentials are stored, can grab them and then use them to access other resources as you. So this is a problem that there is no fix for. You cannot fix it without killing single sign-on. And of course, completely killing single sign-on is an extreme measure that some organizations go to, especially the military organizations where they're using key fobs with one-time use passwords, and you've got to authenticate to everything anytime you want to touch it. No single sign-on there, and that is because they want to prevent and completely avoid this type of problem. But as long as you want single sign-on, there's no fix for this problem. Also, just in terms of terminology that you'll hear us use throughout this presentation, there are two types of pass-the-hash attack. One is credential reuse. That is when somebody grabs your credential or credential verifier, and then they, from the system that it's stored on, use that to go authenticate to other resources as you, without your knowledge. This is reusing that credential verifier credential that you've entered into the system. And then the second form we call credential theft. And this one is, attacker gets on your box where you've got your credentials stored, and now they grab those credentials and then take them to another location and use them from there. And this one lets them spread throughout a network. It's through a process we call credential harvesting that we'll cover. So those are the two forms, reusing it from where it is, as you, to access other resources and spread to those other resources, and then also taking those credentials with them as they do that is credential theft. Here's the agenda of the talk that we've got for you over the next 75 minutes. We're going to take a deeper look at the pass-the-hash technique to show you how an attacker actually uses those two types of attacks to spread through the network, just to spend a few more minutes on that. Then we're going to talk about pass-the-hash in Windows, so what kinds of tools and techniques are hackers using to harvest credentials and to use the credentials that they harvest to spread throughout a network. And then we'll get into what are the mitigations that have been introduced in Windows 8.1 and Server 2012 R2 that enable you to try to prevent, to mitigate the effectiveness of pass-the-hash throughout your network to protect your high-value assets and users. And those include, we break that down into local account mitigations, mitigations against passing the hash on domain accounts, mitigations for restricting remote administration access, RDP access, and compromise of credentials in that scenario. And then finally, a feature that is actually a collection of features that together allow you to create what we call authentication policies for certain users and silos that those users, silos of resources those users can access to contain pass-the-hash. So let's talk about single sign-on just a little bit more. This is Sue logging into her laptop, and when she logs into her laptop, and this is a Windows-centric perspective on this, so Sue enters her password. Now Sue gets a user session on that laptop after she's authenticated to it, and her password verifiers, in this case, in the case of Windows in this particular example, we're using a one-way hash, also known as an NT one-way function of her password that's stored on the box. And now that that's there, she can go access a file server. And when she accesses the file server, there's a challenge response from the file server to have Sue prove that she really is Sue. And what happens underneath the hood is that Sue proves that she knows the password by using that one-way function in that challenge response. So once Fred then knows that Sue knows that password that Fred is also aware of, or that file server is also aware of, then Sue gets a session on that file server and now can access the files on that server. In the pass-the-hash attack, we've got Fred. And Fred's got a user session here. He's already authenticated, so he's got his one-way function stored in the system. Now a bad guy takes over Fred's machine. Or Fred himself is malicious. And now Fred, or the malware, takes that password hash and authenticates or copies it to its own session potentially, so it's not reliant on Fred being logged in any longer, and this would be a theft scenario. Takes that credential, so now Fred can actually log off, his session destroyed, but the malware has Fred's one-way function, his hash, in its own session, and now it can go around the network as if it's Fred. So the malware attackers usually perform some kind of reconnaissance, either beforehand or while they've got their presence on that server. So they'll do port scanning and check out what file servers are accessible to this machine, and then they identify targets to go to. This is called lateral movement throughout the network. And so they'll say, oh, Sue's laptop. Looks like Sue's laptop might be an interesting target. And let's try to authenticate using Fred's credentials to Sue's laptop. And assuming Fred has access to Sue's laptop, then a session can be established for the malware on Sue's laptop. What makes it worse is if Fred has local administrative access or rights on Sue's laptop. With the local administrative rights, now the malware can now harvest Sue's credentials off that laptop. And so this is the credential harvesting now. The malware has Fred's credentials, the malware picks up Sue's credentials, and Sue, let's say Sue's a domain admin. If Sue's a domain admin, now the malware has domain admin credentials, and say this is the domain controller or a domain controller file share on the domain controller.